Now let us study Wacker process. Okay, now what is Wacker process? In this reaction, you convert ethene to acetaldehyde. Now there are many related reactions also. Okay, which works on similar basis. Okay, now this is palladium catalyzed reaction. You start with it with the palladium 2, and here in the end of the reaction you will get palladium. That means here you will reduce the palladium 2 to palladium 2 to palladium. Now palladium is again reoxidized. Now if you see the reaction, suppose this is your palladium. Now palladium 2 is reoxidized to palladium 2 in presence of copper. Copper will oxidize palladium to palladium 2 divalent, and, and this is how it works. So in this reaction you require copper chloride also. You require copper chloride also for reaction or to continue the reaction. Otherwise that palladium will become non-reactive as it will become palladium 0. In this reaction you require palladium 2 for the reaction. This is your Wacker process. Now how it works? Now, as I already told you that this is your ethene plus water, you will get your acetaldehyde. Now in this conversion the palladium 2 will convert to palladium 0. Now this palladium 0 again it is oxidized by copper 2, and that copper 2 in turn will become copper 1, that is cuprous. Cupric will become to cuprous, and this cuprous again get oxidized in atmospheric oxygen to get your cupric. So this is how these cycles continue, and your palladium 0 again regenerates to palladium 2. So this is how it works. Otherwise that you require almost equivalent amount of palladium, that means stoichiometry amount of palladium 2 you require to convert the reaction, and that will be not economical feasible. So now let us see the reaction mechanism. Now let us I told you that it is we are taking palladium 2. Okay, now this forms a complex with water and ethene. Okay, so it will form a complex with water and ethene. Here also the oxidation state of the palladium will not change. Then chlorine will be displaced by OH minus. So we'll get your okay. Then beta elimination of hydrogen will take place. Beta elimination of hydrogen will take place, and you will get this type of complex. Okay. Again, the oxidation state of palladium is not changed. It is one and the same. Oxidation state of palladium is not changed. It is same. So this is your re-addition of hydrogen to the organic species. Okay, so you will get this type of compound. Okay, the CH3 palladium chlorine. Again the oxidation state of palladium is not changed. Now you will have reductive elimination. In reductive elimination your product will be separated out. So this is your reductive elimination, and your palladium will become palladium 0. Okay, along with this product you will get HCl also. So your palladium will released in the form of palladium 0, that is in reduced form. Again, this can be converted by addition of cupric chloride in presence of oxygen. So this you will get your palladium chloride again regenerated, and this cycle continue. So what is the process? In first step, we will get a complexation with palladium chloride of water and ethene. Then attack of OH minus, this nucleophilic attack on the organic molecule. So chlorine will be released here. Again, here it is. Again, the oxidation state is 2. Then the beta elimination of organic molecule of that species. Then readdition will give complex. Again here having palladium 2. Then elimination. This is called as reductive elimination. Reductive elimination. So your palladium 0 will form and product will be released. This is your product, required product. And this again palladium 0 is oxidized by cupric chloride, and palladium chloride is again regenerated, and the cycle continue. This is called as Wacker's process. Now there are various additions and various types of reactions which is very much similar to this. We will discuss here now. Okay. Now for example, in the type reaction we can see this is the major applications. Major there are many applications of Wacker reaction. So if we have like NaCl, there we have water, here we have NaCl. So in presence of palladium chloride, you have cupric chloride and oxygen, you will get your vinyl chloride. Now if we have C2H4 plus sodium acetate, again the same reaction condition as like Wacker, you will get vinyl acetate. Okay, if you have another application, suppose if you have cyclic compound like this, again in presence of Wacker condition, Wacker like condition, and of course water here, you will get your cyclohexene to cyclohexanone. There are many such applications of Wacker type reactions. So these are the few examples. Okay, so this is your Wacker process.